Hello, this is a work through of 91262, the NZQA Level 2 Mathematics and Statistics Examination 2025. Apply calculus methods in solving problems. Let's have a look at the questions. A function f is given by f of x equal to 2x cubed minus 3x squared plus x over 2 plus 7. Use calculus to find the gradient of the function at the point where x equals negative 1/2. So the gradient is given by the derivative evaluated at the point. This is our point, and this is our function that we need to differentiate. So yeah, the steps are differentiate, and evaluate. Differentiate f of x and evaluate f primed at negative 1/2. And that will give us the gradient of the function at that point. So let's go about that. To differentiate, if you've got a power, x to the power b, with a constant in front, say, and you want to differentiate that, what you do is you bring the power in front, you multiply it, and you reduce the power by 1. So that's our technique. And we do that for each of the terms. We do it for each term in the function f of x. So we want to find the derivative. So 3 times 2 is 6x, reduce the power by 1. 2 times 3, it's got a minus sign, is also 6, and reduce the power by 1. X to the power 1 is just x. When we've got x, when we reduce the power by 1, we get x to the naught, which is 1. And so that just gives us a half. And when we differentiate a constant, we get 0. The power is, this is 7x to the power of 0. 0 times something is 0. So it's just, we just lose that. And then we evaluate this at the point given. So it's 6 times negative 1/2 squared minus 6 times negative 1/2 plus 1/2. Half squared is a quarter, so it's 6 over 4 minus and minus. So it's going to 2 minuses here. It's going to be plus 6 over 2 and then plus a half. Now this one cancels to 3 over 2. So 6 and 3 is 9 plus 1 is 10. 10 over 2, which is is 5. And that's our final answer. Part 2 for the cubic, find the equation of the tangent. So to get an equation of a tangent, it's very similar to the last one. We need the gradient of the function is the gradient of the tangent at each point. So we are going to find the derivative, so our steps are going to be differentiate, evaluate, to get gradient of tangent, and then the equation of the tangent, which is a straight line, is given by y minus y naught equal to the gradient times x minus x naught. and x naught, y naught here is 2, that's our x value, and y naught will be the function evaluated at 2, so that tells us a point. So we've got a point on the curve, and we work out the value of the gradient, and then we throw it into this expression here to get an equation for the tangent. So let's go about differentiating. 3 times something over 3, the 3's are going to cancel, so we're just going to get minus x squared. 2 2's are 4, minus 3, and the 6 goes to 0. So that's our derivative. We want the derivative when x equals 2, so it's minus 2 squared plus 4 times 2 minus 3. 2 squared is 4, then the minus sign. It's order of operations things. The power goes before the negative, the subtraction. 4 2's are 8, minus 3, so that's 8 minus 7, that's just 1. That's going to be our gradient. And then the function evaluated at 2 to get our y value is minus x cubed over 3, 2 cubed over 3, plus 2x squared, 2 times 2 squared, minus 3x plus 6. 2 cubed is 8 over 3, so minus 8 over 3 plus 8, and 3 2's are 6 plus 6, minus 6 plus 6 is going to cancel. 8 is 24 over 3. Just multiplying by 3 on the numerator and putting it on a common denominator basically. So 24 minus 8 is 16 over 3. And so now our equation is y minus that y naught value equal to 1, which was our gradient, x minus 2. That's y is equal to x minus 2 plus 16 over 3. Similarly, this is multiplied by 3 is 6 over 3, so minus 6 plus 16 is 10. So y equals x plus 10 over 3. That's the equation of the tangent. So we're done with part B. Part C. Now this is the opposite. We're given the derivative and we want to find the function. When you integrate, to go the opposite direction, we integrate rather than differentiate. When you integrate, you always introduce an arbitrary constant. And that's what we saw in the previous 2 problems. When we differentiated the constant, we get 0. So whatever the constant is, you get 0. So you can't get back to that constant value without knowing something else about the function, and here they tell us what the local minimum is. So here we're going to, the steps are going to be, let's do that in black. The steps are going to be integrate 2, this will give us f of x, but with an arbitrary constant of integration. Two, we want to evaluate that constant. And we're told that the constant is the local minimum. So evaluate the constant. We've got information about the local minimum from the information about the local minimum. Yeah, let's just have a go and see what we get. So to get f of x, it's going to be the integral of 2x squared plus 2x minus 24 dx. Integration, if we have same thing, ax to the power b, and we want to integrate that dx, we do the opposite of differentiating in the opposite order. So differentiating, we multiply by the power and then reduce the power by 1. So opposite order, we increase the power by 1, that's the opposite. And then instead of multiplying, we divide by the new power. And of course, we've got the a in there. Then we always add a constant of integration. So this is our technique that we're going to use. You only have to add one constant of integration, even though we're integrating 3 terms, because if we added 3 constants of integration, we could just combine them together, added them together, and get one constant. So add 1 to the power. We've got 2x, add 1 to the power is 3, divide by the new power. 2x, add 1 to the power makes it squared, divide by the new power. Minus 24, this is treated as x to the 0, we add 1 to the power, we get x to the 1, divide by 1, don't need to put that in, and then plus our constant of integration. So that's our derivative done. We can cancel the 2's here, which will tidy it up a bit. What about the local minimum? Now that occurs when the derivative, which is equal to 2x squared minus plus 2x minus 24 equal to 0. Technically, that's just giving us the stationary points. Stationary points could be minimums, could be maximums, or could be points of inflection. We will need to check this out. We can actually, I'll come to that a bit later. So we want to solve this. If we divide by 2, it'll make it a little bit simpler. So this is the same as, or it implies that x squared plus 1x, dividing out the 2, minus 12 is equal to 0. And this has got a nice factorization. 4 times negative 3 is negative 12. 4 plus negative 3 is 1x. We'll get in there. So x is negative 4, or x is 3. So there's 2 stationary points. They could be, as I said, minimum, maximums, or points of inflection. Because we've got a cubic here, better without axes. Because we've got a cubic here, we know the graph goes something like this. You don't always have to have a minimum and maximum, but we've found 2 stationary points, so in this case there will have to be one. And the first one will be a maximum, and the second one will be a minimum. That's whenever this coefficient is bigger than 0. Because that's bigger than 0, we go this way. If it was smaller than 0, you would have a cubic that looked like this, and then the first one would be a minimum, the second one would be a maximum. So you could deduce that this is the one we want and this is the one we don't want directly from that sort of general knowledge of what a cubic looks like. But it wouldn't hurt us to determine what sort of turning point, or what sort of stationary point we've got. And you do that second derivative test. And that's find the second derivative. So differentiate this. 2 2's are 4x plus 2. And then look at it at these 2 points of negative 4 That's going to be 4 times negative 4, negative 16 plus 2. Negative 16 is much bigger than in size than 2, so this is definitely going to be less than 0. And that implies a maximum. So that's the one we don't want. 4 times 3 plus 2. Well, both of these are positive. We don't have to know the value. We just know that it's bigger than 0. Therefore, we've got a minimum. Some students, well, many students actually, in my experience, get confused that when this is less than 0, you get a maximum. When it's bigger than 0, you get a minimum. What the second derivative tells us about, the second derivative gives what's called concavity of the function. So the second derivative bigger than 0 means concave. Let's change this to a different color. It means we're concave up. So that means we're going like this, and hence we've got a minimum. And the second derivative less than 0, that one's concave down like this. So we've got a maximum. So that's where the logic comes from. The second derivative tells us about concavity. If it's positive, we're concave up, and if it's negative, we're concave down. And if we're concave up, that means we've got a minimum, and if we're concave down, we've got a maximum. So yeah, so indeed this is the one that we want, and we're told that the local minimum is equal to negative 46. So we've got the original function, which we've just calculated by integrating with the constant, is 2 over 3 x cubed plus x squared minus 24x plus c. And we know that at 3, because that's where we found the stationary point is, that is a minimum, we get 2 times 3 cubed over 3 plus 3 squared minus 24 times 3 plus c has to be negative 46. That means 3 cubed is 27, divided by 3 is 3, 3 twos are not, 3 cubed divided by 3 is 9, 9 times 2 is 18, plus 9 minus 4 23s, 3 20s are 60, and 12, 72 plus c is negative 46. So we get c is negative 46. These are 27, be minus 27 on the other side, plus 72. This is 60 and 13, minus 73, so this is altogether minus 1. And therefore our function is 2x cubed over 3 plus x squared minus 24x minus 1. And that's what the question asks us to find. So we're done there. And we can move on to part D. This question says a cruise ship, the Helena, moves at a constant speed of 5 meters per second. A passenger who missed the ship gets onto a smaller boat. The smaller boat accelerates at 0.5 meters per second squared to catch up to Helena. When the smaller boat leaves the dock, the Helena is already 200 meters away from the dock. Find the distance from the dock at which the smaller boat catches up to the Helena. So these sort of questions, mechanics, distance, velocity, acceleration. If we go this way, from distance to velocity to acceleration, we differentiate. Let's go. if we go, it's going to right over the top, so if we go this way, we are integrate. So we've got information here about the velocity of Helena, and we want the distance, and we've got information about the acceleration of the smaller boat, and we want distance. So we're going to need to integrate to get distance. We integrate once from the velocity of Helena to get the distance that Helena is from the dock, and we integrate twice from the acceleration to get the distance that the smaller boat is from the dock. So let's have a look at that. If we want the distance, which is usually used as S, because we're doing calculus here, if we use D for distance, it would get confusing with our notation D by D X. So physicists and mathematicians usually use S for distance there. That's going to be equal to the integral of the velocity of H dt time. And here we're told the velocity is 5 meters per second. So we integrate that. When you integrate a constant, you just get 5 times t plus an arbitrary constant. I'm going to call this one C0 because we're doing 3 integrations here, and we're going to have 3 constants, and they don't have to be the same. So we need to evaluate what this constant is, and we're told some information in the question. We're told at the time, at t equals 0, we're actually free to choose when t equals 0, but the obvious time to choose is when the passenger gets into the smaller boat, and we're told at that point in time, the distance of Helena from the dock is 200 meters. So that means SH is 200, and that's going to be equal to 5 times no time plus C0, and therefore C0 equals 200. And so we have SH is 5t plus 200. And we're going to be using that later. It's not our final answer, but I'll put it in a box because it's going to be important to us. The smaller boat, which I'll just call B, we've got the acceleration. So we're going to need to first find the velocity of the boat, and that's the integral of the acceleration of the boat, dt, which is 0.5, which is the same as a half, so it's a half dt, and that's going to be a half t plus some different constant, or at least potentially different, as we'll see. And what's the velocity at t equals 0 again? We assume that the passenger is not jumping into a moving boat, so at t equals 0 we have a stationary boat, so the velocity is 0. So that means this is equal to a half times 0 plus c1. This is 0, this is 0, so that means that c1 has to be 0. So we've got the velocity of the boat is a half t. We want the distance the boat is from the dock. That's the integral of the velocity dt, which is the integral of a half t dt. Integration, add 1 to the power, divide by the new power. So divide by 2, we've already got half on the bottom, it's going to be t squared over 4. And plus, as I suggested, a third constant that we're going to be using. The distance, so at t equals 0 again, the distance of the boat is 0 from the dock, starts off at the dock. And this is t squared over 4 plus our constant c2, not t squared, 0 squared. So this is 0, so therefore c2 has to be equal to 0. So the smaller boat, its distance from the dock is given by this quadratic expression, and we want the time, we want the distance, but this has to be, when it catches up to the other boat, it's going to be the same as 5t plus 200, which is the distance of Helena. So we want to know when those two distances are equal. That gives us a little quadratic equation here to solve. We can multiply everything by 4 to get rid of the fraction, so you get t squared is equal to 4 5s are 20t, 4 2s are 800. Put everything on one side to get this in standard form. We've got a standard quadratic we want to solve. This one factorizes. 4 2s are 8, and they differ by 2, so we get minus 40t plus 20 or 0. So t is 40 or t is negative 20. This one doesn't make sense. We've got a time after we leave, so we don't have any information about what happens before. So this is a solution that would be a continuation of the quadratic, but we can't really assume that the quadratic goes back in time. We're starting from a point at the dock. So we know that they catch up after 40 seconds. Small boat catches Helena after 40 seconds. The question though was, what's the distance? How far? So that's the small boat distance is t squared over 4, which is 40 squared over 4, which is 1600 over 4, which is 400 meters. And we can check that as well, because Helena has to be the same distance, and that Helena is 5 times 40 plus 200. 5 4s are 20, times another 10 is 200, plus 200, that's 400. That checks out very nicely. So we find that they catch up after 400 meters. This is our final answer. Anyway, thanks for watching. If there are any questions, put them in the comments, and I'll see you next time with question 2, and then after that question 3, and we'll have this 2025 calculus examination level 2 done for your use in revision and learning.